Hello, we have some exciting stuff planned for you today. The first thing we're going to look at is the dot product, also known as the scalar product. The dot product between two vectors, vector A and vector B, is defined to be the magnitude of vector A multiplied by the magnitude of vector B multiplied by the cosine of the angle between the two vectors. Now just remember that the angle between two vectors, vector A and vector B, is the angle between them when they are joined tail to tail. So just remember that. Now I thought it would be good to just look at a simple example of how we can calculate the dot product. So you'll need to go to your textbook or to your CD-ROM, and while you're doing that, I'll go to mine. Now we're going to do exercise 2C, question 2, part C. Now we have two vectors, and basically we're asked to find the dot product between them. Now the vector A, they told us, is 2i minus j plus 3k. And we're dotting that with the vector 3i minus 2k. Now, the way this works, let's just have a little side note for a moment. We're going to expand all of this stuff out, just like we did when we were back in kindergarten. But probably a useful thing to recall or to remember is from the definition, I dotted with I is going to be the magnitude of I, which is 1, times the magnitude of I, which is 1, times the cosine of the angle between them, and the angle between them is 0, and the cosine of 0 is 1 as well. So in fact, I dot I is equal to 1. And it's not hard to see that in fact that will be the same as j dotted with j, and that'll be the same in fact as k dotted with k. So when we're trying to work out this dot product, we don't actually have to expand all this stuff out. All we're really interested in is where i's will be dotting with i's, and where j's will be dotting with j's. Doesn't seem to be any j in this one, that's handy. And where k's are dotting with k's. Now, the 2i dotted with the 3i. We know that I dot I is going to be 1, and 2 times 3 is going to be 6. So this is going to give me 6. The j dotted with, there's no j's there. There is in fact 0 j there. So even though j dotted with j will be 1, that gets multiplied by the 0. And so in fact, there's no contribution, that's going to be 0. And finally, the 3k dotted with the minus 2k, well we know k dotted with k will give us 1, and the 3 times the minus 2 will give me a minus 6. And the result is 0. Now a couple of things I want to point out. It's called the dot product because there's a dot between the two vectors. It's also known as the scalar product because the result of doing this particular multiplication is a scalar, a number. You always get a number, okay? Now, the fact that the dot product is equal to 0, that's very, very interesting. I wonder what it means about the angle between those two vectors. We know that the magnitude of A and B is certainly not 0. They've got a magnitude. So we're drawn to the conclusion that perhaps the cos of the angle between them is what's going to be 0. And the cos of an angle equaling 0 means that the angle will be 90 degrees. So in fact, these two vectors are 90 degrees to each other. They're perpendicular. That gives us a rather handy way actually of testing if two vectors are perpendicular. And now that I think about it, this is going to give us a handy way for working out the angle between two vectors, whether it's 90 degrees or not. Cut.